There's this very specific, almost terrifying moment in any engineering project. You spend weeks, maybe months, just looking at diagrams. You talk about best practices. You debate all these design patterns in the abstract. It's all very clean, very theoretical, and safe.
And someone hands you a shovel.
Exactly. And says, okay, break ground. And looking at the materials for Class 12, that is precisely where we are right now.
The rubber is meeting the road.
It is, the theory phase. It's over. We are staring down the barrel of the semester-long project. And frankly, when I first saw the word Mancala on the syllabus, I kind of rolled my eyes. I thought, stones and pits, that's a weekend script. I'll knock that out on a Saturday.
I think a lot of people make that exact mistake. They hear board game and they just think toy.
Right.
But the mission of this deep dive is to, completely shatter that illusion.
Yeah.
We're parsing the Class 12 lecture slides, the surprisingly dense CS326 requirements wiki, and we're using the syllabus just for a bit of context.
And what we're finding is not a toy game.
Not at all. It's a case study in how you transition from just coding in a vacuum to managing the absolute chaos of enterprise software.
So we have two main pillars to get through today. First, the project itself, which as I read deeper, turns out to be, a full stack economy disguised as a board game.
Very much. And second, the tool Scrumwise.
Right, which seems to be the only thing standing between the students and just total administrative collapse.
It really is a pivot point. Up until now, the focus has been on the toolkit, Ant, Junit, Git. Now the focus is squarely on the product. It's a shift from, can I write code that runs, to
can I build a system that survives contact with a real user?
Exactly that.
So let's start with the project, Mancala. For anyone who doesn't know, it's an ancient game. 2 players, board with pits, you move seeds or stones, simple mechanics.
Very simple.
But then you open the CS326 requirements document. And I'm counting 4 distinct categories of requirements here. We've got backend, gamification, logic, and front end.
And if you start reading that backend section, specifically, let's see, items BE01 through BE11, that is where the whole weekend project idea just goes to die.
Right. I was looking at BE04, save and resume games. Now, to a non-programmer or even a beginner, that sounds pretty standard, save my game.
Yeah.
But from an engineering standpoint, what are we actually asking the system to do there?
You're asking for full state serialization.
Okay, break that down.
Well, think about it. The server can't just keep the game running in its memory. Memory is volatile, right?
Right. Server restarts, it's gone.
If the server restarts or the user logs out for 3 days or your internet blinks, that data is gone. So you have to take the live object, the board configuration, number of stones in every single pit, whose turn it is.
Everything.
Yeah. And convert that into a format, usually JSON or maybe a database row, that can just sit cold on a hard drive.
And then bring it back to life perfectly later on.
Perfectly. You have to reverse the process. If you drop one integer, or if you load the whose turn it is variable incorrectly, the game state is corrupted. The user comes back and the board just looks wrong. That's a critical failure.
And that must tie into BE01 and BE02, the whole identity thing. You aren't just playing as guests.
No, you need a persistent user account, which brings up a huge compliance issue hidden in BE02.
Which is?
It mandates collecting birthdays to reject anyone under 13.
Oh, right. The age verification.
It seems like a simple A-fills check, doesn't it? If age is less than 13, say no.
But it's not.
But technically, you are now handling PII, personally identifiable information. You're storing birth dates. You can't just leave that in a text file or some non-secure database. It completely changes the security posture of the application. You suddenly have a real responsibility to protect that user data.
Okay, but the part that really surprised me and where I think the complexity just spikes was the economy. I did not expect a student project to have a digital wallet.
It's mimicking the modern freemium gaming landscape. I mean, look at requirement BE07, token balance tracking.
And BE09, token purchases via microtransactions.
So they have to build a bank.
A bank, not just a ledger.
Right. You can't just have a variable called user money that you add to. You need to track transactions. Imagine this. A user buys 50 tokens. The system writes to the database to deduct the cash, but then the network crashes before it confirms that the tokens were added.
Oh, no. So they lost the money but didn't get the tokens.
Exactly. Or the other way around, which would destroy your economy. Dealing with that transactional integrity, what we call ACID compliance in database terms, that is a massive leap from hello world. You need a history. Where did every single token come from and where did it go?
And they aren't just hoarding these tokens, they're spending them. This is where the gamification section of the requirements gets.
Well, it gets wild. Requirement GF10 talks about variable consumable cards.
This is the feature that breaks the clean logic of Mancala.
How so? Standard Mancala is deterministic. The rules never, ever change. But GF10 introduces cards that can, grant an extra turn or modify pits in the middle of the game.
So if I'm the developer writing the game logic, I can't just code the rules of Mancala.
No.
I have to code an engine that accepts rule-breaking injections at any time.
Precisely. Your logic has to be flexible enough to handle exceptions. If I play a Steal Stones card, the game engine has to pause the normal flow, execute that card's logic, update the state, and then somehow return to the normal flow.
That is an architectural challenge, not just a coding one. It sounds like a complete nightmare for the logic programmer.
It is. And then you have to balance that economy with the gameplay. Did you happen to catch the distinction in requirement GF04? The one about the pay-to-win mechanics?
I did. It was very specific. It says winning against a human grants tokens, but winning against the AI does not.
And that is a crucial design choice. If you gave rewards for beating the AI, what would users do immediately?
Oh, they'd write a script to beat the AI 1,000 times an hour and crash the economy. They'd become token billionaires overnight.
Exactly. They're designing against exploitation. It's a great lesson in incentive structures. If you build a system that can be farmed, you have to assume users will farm it. The requirements team here actually thought through the economics of it all.
Even the front-end requirements are picky. FE09 demands terminology modernization, getting rid of seeds and pits, and FE04 requires a sound effects toggle.
Accessibility and polish. It's easy to hard-code a sound effect. It's much harder to build a global setting that suppresses that sound effect everywhere because the user clicked mute. These are the things that get forgotten in student projects, but in the real world, they're mandatory.
So let's pull back. The big picture here, the takeaway, is that students aren't just coding an algorithm. They're building a secure, state-maintaining, economy-driven, multiplayer platform that just happens to feature Mancala.
Exactly right. And if you try to build that without a plan, you will fail. You cannot build this by just emailing code snippets back and forth.
No, you need a process. And that leads us to the second pillar of this deep dive, the tool, Scrumwise.
Scrumwise. This is the command center for the whole operation.
So the lecture slides introduce Scrumwise as the specific platform the class will use. We've talked about Agile and Scrum before, breaking work into sprints, but this is very specific about how to use this dashboard.
It's really a visualization tool. When you're working alone, the plan is just in your head. But when you have 5 people or 10 or 50, the plan has to be on a screen that everyone can see.
And it looks pretty standard. You have your tasks, your backlog. But there's a small detail in the slides about the People tab that was really emphasized.
The profile pictures.
Yes. The instructions explicitly say adding an image makes it easier to quickly see who owns a given task.
It sounds so trivial, doesn't it? Just a cosmetic thing?
It does.
But have you ever looked at a Kanban board with 50 tasks on it? If every avatar is just a generic gray silhouette with initials, your brain has to read every single one to figure out what's going on.
It adds friction. A lot of friction.
It's cognitive load. If you see a face, even a cartoon avatar, you instantly recognize, oh, that's Sarah's task, that's Mike's task. It allows for rapid information processing. It's about making the project state readable at a glance.
Okay, so let's break down the structure. The work is done in sprints.
Right. A sprint is just a cycle, usually 2 to 4 weeks. In that time, you design, build, test, and deploy some chunk of the software.
And the thing that tracks if you're actually doing anything is the burn down chart.
The burn down is the truth teller. It's the heartbeat of Scrum. It's a simple graph, time on the horizontal axis, remaining work on the vertical. Ideally, you want a nice diagonal line sloping down to 0.
But here's the kicker. The slides say students have to log everything. All work must be tracked, including applied time. That feels intense. Do I really need to log the 15 minutes it took me to fix a typo?
You do. And I know it feels like micromanagement. It can feel like surveillance.
Roger.
But the reasoning here is so crucial. It's all about data. The slide says this tracking is to inform future estimating.
Ah, so it's a learning tool.
It's purely for learning. The reality is, junior engineers are terrible at estimating. They're optimists. They say, oh, I'll have that login screen done in 2 hours.
6 hours later.
6 hours later, they're still debugging the database connection. We've all been there. But if you don't track the actual time and compare it to your estimate, you never learn how wrong you were. you just keep lying to yourself.
It forces honesty.
It forces calibration. The burn down chart immediately shows if the team is stalling. If you're 3 days into a sprint and that line is flat, no work being marked as done, you are in trouble. It forces the problem out into the open for everyone to see.
So we have the Project Mancala on steroids. We have the tool Scrumwise. Now let's talk about the assignment. What do the students have to do right now?
The immediate workflow is fascinating. It really mimics a real software consultancy. It starts with the client, the instructors creating user stories.
Like, as a user, I want to log in so I can save my tokens.
Exactly. Then the requirements team hands those out. The dev teams then have to translate those stories into use cases on the wiki. But the hard part, the part that's really highlighted in the slides, is partitioning.
The divide and conquer phase.
It is, but it's an art form.
Yeah.
The team leaders have to break a use case down into partitionable tasks. And there are strict rules. The slides mention a 2-week rule.
What's that?
No task should be estimated over 2 weeks. If you look at a feature and think, that'll take me 3 weeks, you aren't allowed to make that a single task. You must break it down.
Why? Is it just to make the board look like you're doing more?
No, it's to manage risk. If I give you a 3-week task, and 2 weeks in you get stuck, or you get sick, or you drop the class, we have 0 deliverable code. Nothing.
I see.
But if I break it into 3 one-week tasks, and you get stuck on the second one, we at least bank the first one. We have tangible progress.
It's about having secure checkpoints. That makes sense.
And the other concept the slides hammer home is orthogonality.
Orthogonality. That's a $10 word.
It basically means independent. In this context, tasks shouldn't overlap or depend on each other too heavily. You want to prevent developers from tripping over each other.
Oh, okay. So if I can't start building the wall until you finish coring the foundation, we have a dependency problem. We're stuck.
Right. If tasks are tightly coupled, you get bottlenecks. The assignment explicitly mentions loose coupling. You want to define tasks so developer A can work on the database schema and developer B can work on the front-end layout, and they can work in parallel without talking every 5 minutes.
That requires some seriously good planning up front.
Which is why there's so much emphasis on this setup phase. The slides even warn that if you don't partition orthogonally, you get merge conflicts. You get 2 people rewriting the same file. It's just chaos.
And the goal of Scrum is a working version at the end of every sprint.
That is the golden rule. You can't have a sprint end with, well, the code is 90% done, but it doesn't compile. That counts as 0.
Brutal, but effective. Now, all of this leads up to a very specific date.
Monday, February 23rd.
That is the deadline for the first sprint planning meeting.
Correct. By class time that Monday, the teams need to have all this prep work done. They need enough work defined so that every single person on the team has a full workload for the first sprint.
And looking at the syllabus, this really matters for the grade. The development shop component is 45 points. That's almost half the grade.
It's huge. And there's a very specific bolded note in the assignment slides. Each team member is responsible for ensuring they have adequate tasks to account for their 20 hours.
Wait, 20 hours?
That's the expected contribution per student for the sprint. And the phrasing is interesting because it puts the responsibility on the individual. You can't just sit back and wait for the team leader to assign you work.
You can't say, oh, well, nobody told me what to do.
Exactly. That excuse doesn't work here. If you show up to that planning meeting and you only have 5 hours of tasks assigned to you on Scrumwise, you're effectively saying, I plan to slack off for the next 2 weeks. You have to actively hunt for tasks to fill your bucket.
It sounds like they're trying to simulate the autonomy of a senior engineer, or at least weed out the passengers.
We've all been on those group projects, right? 1 person does the work, 3 people watch. This system, Scrumwise, the burn down, the time logs, it makes it mathematically impossible to hide.
And that meeting on the 23rd isn't just a starting gun. The slides say it's an opportunity to refine the plan.
That's the planning part of sprint planning.
Yeah.
You all sit down, you look at the tasks, you look at the estimates, and you ask, is this realistic? Did we miss anything? Is this task actually a dependency for that one? You argue about it, you adjust the estimates, and then you commit.
It sounds remarkably like the real world.
That is the entire point.
Yeah.
They aren't grading you on whether you can write a for loop. They assume you can do that. They're grading you on whether you can deliver software in a predictable, professional manner.
You know, connecting back to the requirements for a second, I keep thinking about how easy it would be to underestimate something like GF11 card acquisition. Cards can be bought with tokens and/or earned through gameplay.
Oh, that's a classic trap. A huge one.
Right, because you think, okay, I'll just write a function bytecode, but then you realize, wait, I need a UI for the shop. I need a database check for the token balance. I need a transactional update. I need to handle the case where the transaction fails. Suddenly, that one task is actually 5 tasks.
And if you estimated it at 2 hours and it takes 10, your burn down chart looks terrible and your team is behind schedule.
Oh.
This is why the assignment asks for use cases first. You have to think through the user's flow step by step before you write a single line of code.
It's rigorous.
It has to be.
Before we wrap up, I wanted to touch on one interesting visual from the source material. It was in the slide deck, labeled LLM Roundtable. It showed a graphic about the productivity paradox of AI coding assistants.
Ah, yes. And this ties into the syllabus, which mentions the use of BitBuddy and AI tokens.
Right. The slide asks a pretty provocative question. We have all these tools now, Scrumwise for tracking, AI for coding, but do they actually make us faster?
It's a valid concern. The productivity paradox suggests that sometimes the tools we use to manage work actually create more work. We spend more time managing the Scrum board and prompting the AI than we do actually solving the problem.
Administrative overhead.
Exactly. If you spend 2 hours configuring Scrumwise and 3 hours prompting an AI to write code that you then have to spend 4 hours debugging because it hallucinated a library that doesn't exist, are you actually moving faster?
That's the danger, isn't it? You change from being a creator of code to just a manager of tools.
Correct. But I think the counter argument, and what this class is trying to teach, is that the overhead buys you certainty. Sure, you could probably code faster if you didn't have to write user stories or update Scrumwise.
You build the wrong thing?
You'd build the wrong thing. Or you'd build something that just breaks immediately. So the slowness of the process is actually the speed of getting it right the first time.
Or at least catching the mistake in week 1 instead of week 10.
That's Scrum. It's about failing fast and recovering rather than failing slowly and catastrophically.
Which brings us right back to Monday, February 23rd. The plan has to be ready.
The plan has to be ready. And for the listeners who are taking this class, do not overlook the details in that requirements wiki. Go read BE12 about the invite plus rules approval system.
Yeah.
Go read FE10 about platform flexibility. These aren't suggestions. They are the contract.
And make sure you have your profile picture up on Scrumwise.
Please. Your team leader will thank you.
All right, let's wrap this up. We've covered the Mancala project. It's big, it's complex, it has a whole economy. We've covered Scrumwise, the dashboard, the sprints, the burn down that tracks your soul.
I mean, your applied time. Close enough.
And we've covered the immediate deadline, Monday, Feb 23rd. Partition your tasks. Ensure orthogonality. Fill your 20 hours.
And remember, the easy part playing the game is over. Now the engineering begins.
Thanks for listening to this deep dive. Good luck with the planning meeting, and we'll see you on the next one.
Happy code.